I decided to make two parts, a Unit 2 Part 1 and Part 2. Part 1 covers slides 2, 3, 4, 7, 8, 9, 10, and 11. For many of you, I had an opportunity to go through this in class, but this is a second opportunity for you to listen to the explanations again. So, did you know that this picture on the right here represents a system of equations? It does, believe it or not. So let's look at this problem comes from slide 2. Here are two equations. We've got the red graph and the blue graph. So this equation goes with the red, and this equation goes with the blue line. What we're supposed to do is decide if the ordered pair of 5, 4 is a solution to one equation, both equations, or neither of the equations. So the very first thing that I want you to do, or you should do, is graph the point 5, 4. As you can see, I've labeled 5, 4 in purple. And I want you to note that that point lies on the red graph. Therefore, that point is a solution to this equation of 2x plus 5y is equal to 30. So therefore, 5, 4 is a solution to 2x plus 5y right here. So I'm going to indicate that. Moving on to the next slide. We've got slide 3, which is the exact same graph again. This time, nothing has changed other than they're asking us to decide whether the ordered pair of 0, 6 is a solution to one equation, both equations, or neither of the equations. So what I'm going to ask you to do right now is to graph the point 0, 6. As you can see, I've indicated the ordered pair of 0, 6 on the graph, noting that it sits at the point of intersection. Therefore, it is a solution to both equations. As you can see, I've now written both equations, and I want to make sure and point something out. My ordered pair is x, y. 0 is my x value, and 6 is my y value. What this means with it being a solution to both equations is that I could substitute 0 in for x into the first equation and into the second equation, and I can substitute the value of y, which is 6, into the first equation for y and into the second equation for y. And when I actually simplify and solve, that the left-hand side and the right-hand side, so the left-hand side of this equation will be 30, and the right-hand side is 30. Therefore, I know that the equation is true and balanced. And the second equation will be 12 on the left and 12 on the right. Therefore, I know that both equations are balanced. They both have the same solution on the right and the left. Therefore, they are solutions. This ordered pair is a solution to both equation 1 and equation 2. Here's the last slide, slide 4. And again, it's asking you whether the ordered pair of 1, 6 is a solution to one, both, or neither of the equations. As I've done in the previous two slides, what I'd like you to do is graph 1, 6. As you can see from the graph, 1, 6 does not sit on the blue line, which is the 5x plus 2y, or the red line, which is 2x plus 5y. Therefore, because it sits on neither line, it is not a solution to either equation. Remember, solutions sit on the line, and a solution to a system is the point of intersection. We're now going to move on and look at slide number 7, because slide number 5 was a summary slide. Slide number 6 asks for you to graph 2 equations, and you're not going to be asked to do that on this exam. So on slide 7, you're asked to indicate or tell which method you would use to solve the various systems. So I have 3 systems here, 1, 2, and 3. I'm going to look at each one individually and decide which method, graphing, substituting, or elimination, would be the best method to use. So on the slide I've indicated, and you see in red that I've circled plus 3y and minus 3y. If I were to simply take these 2 equations and add them down, you could see that I can eliminate the 3y from both equations. I would therefore use elimination to solve this system. In system number 2, I've underlined in blue that y is equal to 2x. Therefore, in the second equation, wherever I see y, I could substitute 2x in for y right here. Therefore, when I look at equation 2, I only have the variable of x. So I can therefore quite easily solve for the value of x by adding 2x and 2x, which I know is 4x, and that's equal to 4. Therefore, what would make the equation true? That x would be equal to 1. So 4 times 1 is 4, and 4 is equal to 4. Therefore, I could easily find the value of one variable and then find the value of the second variable. In the very last system, because I'm looking at it in great detail, I'm noticing that I can't add the 2 equations together, nor can I subtract them, because if I add or subtract them, I don't eliminate a variable. So to me, the easiest method to use would be to graph. So I would open up a graph on Desmos and input both of these equations and then find the point of intersection in order for me to solve. Moving on, this is slide 8, and on the exam you're going to be asked to find a value of x that's going to make an equation true. In this case, we want to know, again, what value of x would make this equation true. What that means is, when I find a value of x, that because the right-hand side is equal to 15, I need to find what value of x on the left is going to make that equal 15 as well. So you could see I need to find a value of x. There are a number of ways that I can do this. I think the way that most of you would choose to do it would be to solve and get a value of x. So let me go ahead and start that process by rewriting my equation. So remember, when I solve, I need to get the variable all by itself. And right now, the x variable is being divided by 2. So in order for me to isolate the x, the very first thing I need to do is subtract 3 from both sides. When I subtract 3 from both sides, I have x over 2 is equal to 12. So now I can look at this equation and I can say, okay, what value of x do I have or do I need that when I divide it by 2, it equals 12? So what I can do is, I know that if I take 24 and divide it by 2, I know that the answer is 12. So x, in this case, the way I just solved it, x is equal to 12. That means that if I substitute this value of x right here into the equation, that the left-hand side will be equal to 15 and the right-hand side will be equal to 15. X actually isn't equal to 12. What I should have said was x is equal to 24, because that's what I wrote in my equation. So let me make that change right here. So 24 divided by 2 is equal to 12. So, because that was what I was solving for. So the value of x is 24. And when I substitute x for 24 back into my original equation, the right and the left side will be balanced. So 24 divided by 2 plus 3 is equal to 15. 24 divided by 2 is 12, plus 3 is equal to 15. Therefore, 15 is equal to 15. So there is my solution. That's one way to solve. Let me show you the other way that I could have solved this equation. I'm going to go back and rewrite x over 2 plus 3 is equal to 15. Again, I'm going to note that I want to isolate x over 2, and by doing that, the very first thing I'm going to do is I'm going to subtract 3 from both sides, just like I did before, which leaves me with x over 2 is equal to 12. Now, in this case, you're going to see that I'm dividing x by 2, so I can use the inverse operation of division and use multiplication. So if I multiply both sides by 2, what that means is 2 divided by 2 is 1. Therefore, I'm left with x on the left-hand side. And now I simply simplify 12 times 2, which is 24. You can see that I got the exact same solution. So like I said, there's a number of ways that you could have worked this out, providing that you show your work or you explain your work when asked. Moving on and looking at the next slide. Slide number 9 asks you to model a situation. So in this case, when we say model a situation, that means we're going to write equations based on the information that we have in the problem. So Roxy is buying toys. 2 balls and 4 dolls cost $8.20, and 3 balls and 1 doll cost $6.50. It tells us we're supposed to write a system of equations to model the situation. So why is this a system? Because Roxy is buying toys. She just happens to be buying toys in 2 different situations. The first time, she buys 2 balls and 4 dolls, and she spends $8.20. The second time she buys dolls or toys, she buys 3 balls and 1 doll, and this time spends $6.50. So 2 different situations, but they're related in that she's buying balls and dolls. So let's look at each situation individually and be able to write our equations that way. So the first case is Roxy is buying toys. She bought 2 balls and 4 dolls. So down here, it tells us, let X represent the cost of a ball and Y represent the cost of a doll. So we know she spent a total of $8.20. So what did she buy for $8.20? She bought 2 balls. We have no idea how much they cost. So 2x plus 4y equals $8.20. That's our first equation. Our second equation is very similar in that now she, instead of buying 4 or 2 balls, she bought 3. So 3x. And how many dolls did she buy in the second case? She bought 1. So I can write 1y. How much did she spend this time? She spent $6.50. So again, we have 2 equations. We weren't asked to solve this. We were simply asked to write the equation. Related, but different because they're 2 different situations. Slide number 10 now has to do with determining and interpreting the slope. So let's do the first thing of determining slope. So I want you to remember that slope is considered a rate of change. Is how is something changing over an interval. In this case, our rate of change is always the change in the y over change in x. So what is the y? The y is packaging. So this is going to be the change in the cost of packaging over the change in the weight of my fruit baskets. All right, so now that we've got that, I want you to remember that when we talked about slope in class, I said the easiest way to think about this is the rise over the run. How much is the y changing over the x? So let's look at our 2 points on the graph. We're given that the first point is 3, 10, and the second point is 6, 16. So remember, I'm going to look at the rate of change or the change in y. So my vertical axis is the change in y. So take a look at the numbers on the graph. We start at 10 and we go to 16. What is the change in those numbers between 10 and 16? You're going to hopefully note that it is 6. Then I'm going to look at the change in x. So from this point to this point, how much did it change? So this is the rise over the run. How much did x change from 3 until 6? It changed 3. So my slope is 2 over 1, or simply 2. So what that means, the cost, the slope tells us that the cost is changing by $2 for every, how are we looking at the weight of baskets? In pounds. For every 1 pound of my fruit basket. So that is how my packaging and shipping cost is changing. So now it asks us to interpret the y-intercept. So remember, on my graph, this is the y-axis. So the y-intercept is where does my line cross my y-axis. So right there I can write the ordered pair of the x is 0. So that means the weight of my basket in pounds is 0. And 4 is my y value. This is a cost, $4. Well, let's think about this. Packaging and shipping. Well, we all just figured out that the cost goes up $2 for every 1 pound. So therefore, my container or my packaging of my fruit basket must be $4. So I'm going to say that that's the cost of the box that I have to buy in order to ship my fruit baskets to somebody. So that's what that means. So moving on now and looking, I believe I've got one more slide. This one is about Black Friday. And we've got Black Friday and Cyber Monday. And you could see here from the problem that you bought 3 shirts and a pair of pants right here. And that cost you $30. And then on Cyber Monday, the prices stayed the same. So you looks like you bought the exact same shirt and another pair of pants. And this time you spent $24. So it's asking us to make the assumption that all the shirts are the same price and the pants are also the same price. meaning these pairs of pants are the same price and these t-shirts are the same price between Friday and Monday. So how much were the shirts and the pants? So again, we're going to look at a system of equations. Think back to Roxy when she bought her toys. Well, this is the same thing. We're buying something, but we're buying it on different days. Day 1 is Black Friday. Day 2 is Cyber Monday. So let's go ahead and assign some variables. I'm going to actually use S for shirts. This is a shirt. And P for pants. Because it doesn't tell me I have to use X and Y. So how many shirts did I buy on Black Friday? 3 of them. So 3S. How many pairs of pants? 1 pair of pants. And how much did I spend? $30. Okay, let's talk about Cyber Monday. Same thing. How many shirts did I buy? 1 shirt. How many pairs of pants? 1 pair of pants. How much did I spend? $24. So again, 2 equations with the same variable, related, but they're different because on one day I bought one thing and on the other I bought another amount. So they're related because I bought the same thing. So now, how could I solve this system in order to figure out what is 1 shirt and 1 pair of pants? Well, we've used, if I had a graph available, I could definitely open up Desmos and graph this, but I would have to change my variables to X and Y, right? But I'm going to look at this and I'm going to realize that I have 1P and 1P in each equation. So if I merely subtract the first equation, the second equation from the first equation, then I could easily eliminate this the P variable right there. So that's what I'm going to do. So I'm going to subtract 3S and take away 1S, which leaves me with 2S. I know that if I have 1 pair of pants and I take 1 pair of pants away, I have 0. And now I'm going to take 30 and subtract 24, which is equal to 6. Therefore, I can note that dividing both sides by 2, I know that each shirt costs $3. So the shirt that I bought on each day was $3. So if I know what a shirt costs, if I buy a shirt and that was $3, and I bought a pair of pants, and when I bought those two together, it equaled $24. Well, I could easily figure out what a pair of pants is, because if a shirt's $3 and I add 21 to 3, I get 24. So therefore, my pair of pants was $21. And I can go back up here to my very first equation, and if I put in $3 for each shirt, and I put in my pair of pants of 21, that equals 30 for sure, because 3, 6, 9, 9 plus 21 is 30, and I know that that's 24. Therefore, I'm going to happy face when I do that. So, I think, yeah, that's all the problems for part 1. If you need to stop this video at any time, rewind it, go back. Hopefully that'll help you. Part 2 is going to cover the rest of the slides on this Desmos activity.